Matt twisted my arm and he said, please don't give a talk. So this is the first time I've been at your testing meetup, and it's really cool. I haven't actually been at a meetup for a while where I've seen so many people, and really the game is amazing. So all should give yourselves a round of applause for that. Yeah. I don't speak very well. Is that it? All right, if you can't hear me, just put your hand up and I'll try and speak a bit louder as we go. So, okay, cool. My talk's on automated visual regression. It sounds really fancy, so I'm going to try and make it really simple. So to kind of kick this off, what I'm going to do is I'm going to take 30 seconds. The next slide I do is going to have two pictures on the left and the right. And what I want you to do is just take about 30 seconds and see if you can spot the difference between these two pictures, right? There are about 5 things that are different, so that's a clue, right? Okay, just take a few seconds.
Put your hand up, you got it.
Five things, right?
Yeah, 5 things that are different.
All right. So how many people got 5? 1, 2, 3, 4, 5, 6, 7, 8, 9. Matt, how many t-shirts you got? Okay, all right. So tell me one thing. The belly button. All right. Yes. Mouth. Yeah. Say. Yes.
The mouth and the foot.
The foot. Yeah. Perfect.
Yeah.
Oh yeah. 3. Yes. The ear. Yes. Love the ear. Come on, the one that.
The plant.
Yes. The leaves. Yes, the leaves. I did this with a designer and they saw the leaf first. So. Damn it. I think it's the color. Sorry. Is there another one? Okay. Maybe I've got another question later on in the show. So, cool. So, visual regression is really basically what we just did. Right? It's like looking at 2 images and picking up what the difference is. That's really in a nutshell what we're trying to accomplish. So, if we would overlay these 2 images and pop the differences, in this picture, I don't know if it's as clear, but in red you will see the foot, the area of the leaf, the ear, the mouth, and the belly button are the dark red spots. And basically, what I did here was I just used a stock standard piece of software that pixel matches every pixel in each image and creates a composite overlay that pops the differences. So, well done to everyone for getting this. It's pretty cool. But what I find really interesting is if you were to run this, there's also this red outline. I don't know if you actually notice everything on the outline of this image is red. And I took a moment when I spat this image out to kind of why is that outline there? And what I realized was that these are 2 JPEGs and they've been built differently. And actually, when we zoom into the edges of the borders, they rasterize out differently. So there's actually pixel difference on the edge of the entire image. And you won't pick that up. It's really hard to see that vision. You need to zoom in to 200% and be really anal about that and think that that's what you care about. But that's what a computer can do. That's what it's born to do. Pixel match. It can split that out in
Why is it showing the leaves?
So at the same time, it's picking up color density difference. So it's actually the exact pixels. Nice, man. Give us another t-shirt. So great question. But yeah, that is actually that's what's happening. And I tried to take a really trivial image to kind of allow us to start the conversation. But I think what the key difference is it's not the ability to identify the differences. I mean, that's what we can get a computer to do. It's actually then for us to define which of these images right. And a computer will never be able to do that, right? This is where us as people, as humans, this is where we operate at looking at 2 things and saying, well, yes, this one's the one I want, or no, this is the one I want. So I think it'll become a little bit more clear if we put this into a real-world context. And so if we were to take 2 websites, we take this as our baseline, and this is what's currently happening, we can run that through a diff, and quite quickly we can get the hotspots of where it's changed. So in kind of like we were talking about, this whole pink area here, it's pointing out the color's changed. Now we can look at that and say, geez, did we intend the color to change? Do we want that, right? And if we want the color to change, well, that's cool. That's what we want. That's our new expectation. If we didn't want the color to change, well, geez, something broke, right? Like, we don't change color. Blue's our brand color, so please don't change that. But at the same time, which gets a little bit harder to see, is the height of this change. And the height, causing the height, lifts this content underneath. So that's what's represented in there. And so visual regression is about getting to a point where we can be identified as testers and developers to say, geez, something changed, did we expect it or didn't we? And so that kind of like boils into the default workflow of visual regression. So we take the baseline and we compare it to the current. The test will, if the test fails, we've got two choices. Either reject it or accept it. If it's rejected, go back to the drawing board, change your code, make it come back so that there's no change. If we accept that this is what we want, like we knew that we were going to change the button size, we knew that we were going to change the color, so we were expecting this test to break. That's cool. Then we just save what we got. That's our new baseline, rerun our tests, and they should pass. Right? Is that cool? So, you know, like where does visual regression really stand out for you? Where are the places where you can get benefit from using it? And I think, for me, one of the biggest benefits we're seeing at Donovan Graham is we are trying to develop software that caters to multiple devices. So for each screen, we're looking to do it at different breakpoints, different screen sizes, and that means our content sometimes changes shape, sometimes we take things off the page, sometimes we put new content, especially on our mobile platforms. We have to just reimagine what we're doing. On the desktop, we've got plenty of space, we do big tables. On mobile, we've got to go, that table just doesn't work. We've got to come up with a different solution. And in this space, the problem gets compounded because now, not only do you have like a home page, you've got a home page times the 5 devices that you care about. Not only do you have a customer login page, but that 5 times. So your test scenarios just explode exponentially that you care about. So it's also really great at testing things that are super visually dependent. So we're a financial company, and graphs and projecting of the data in a visual format is incredibly important to us. And up until now, testing graphs is just a manual thing. And if Evie can tell us, if I give you over 3,000 data points over the last 10 years on a stock trade, if that graph is right, he just hopes I did my calculation right. So, you know, like, but at this point, if we generate that and we take a picture and we know that that's the baseline, thereafter it shouldn't change. Like if the calculation, we banked that the first time, I don't expect that graph to ever change, right? And then I guess some of the other things, I spent a lot of time doing front-end web development, and we use CSS selectors to elements and check for their existence and things like that. And using the selectors that are based on class names to say, is this item open? Is it visible? Is an inherently broken practice, because just because I gave something a name doesn't mean it is what it is. Well, I've seen guys have this class, they delete it from their CSS, suddenly that element isn't even on the page. But in JavaScript, if I take an item and I float it off screen, I can still click it in JavaScript. But a user on a device will never be able to click something that is not on their screen. So I think there are some very important use cases around being able to actually look at the visual and make judgment calls from that. We just need to do it in an efficient way. The other thing that is quite important is as we explode the number of screens and the number of devices and the number of permutations, we have this interesting thing. As humans, we get mental and visual fatigue. The more we look at things, the more they start looking the same. And so it becomes over time, harder and harder for us to even spot those differences or even notice that they're there. They just all look the same after a period of time. So what we need is those tools that say there are differences. Tell me if you like that. So for me, that's a big win out of this. Okay. So does anyone know who this gentleman up on the top left is?
What is?
Mike Kahn, of course. You said you meant a sixer, right? Cool. So Mike Kahn is a big guy in the Agile community, but he's also quite famous for coming up with the testing pyramid concept. Does everyone know about the testing pyramid? Do a little intro? Yes? Yes, if I must do an intro, put your hand up. No? Yeah, we got a little intro. Okay, so I'm going to do it really, really quickly. It's about tests and the test types that you write. Basically, they're saying, he kind of proposes that unit tests are the fastest tests to run, and they're the cheapest tests to write. So do a lot of them. That's why they're fat at the bottom. As we move up, they become slower and more costly to develop until you're in the top in the UI layer, end-to-end layer. And finally, manual being the most expensive in terms of time and resources. Okay, so as we can see, visual for me would be somewhere up in here. And but what the pyramid doesn't show really is if you were to draw sort of like a horizontal slice around somewhere around the service integration, like contract test level, going below that, what we're getting is functional value, right? Like when I add two numbers, do they give me the number I expect? Like it's really about does the system perform well? And if I go above the line, what we're actually getting is business value or customer value. Can my user interact and log into my website? That's a whole different set of values that you're actually trying to solve up here. So it might be faster and cheaper to write, given a password it hashes really well, but if my user can't log in, it's pretty relevant. So I kind of want to just park that thought and like let you take that and on your own time introspect on that. But what I'm trying to get at is I don't think you should ignore what's happening at the top of the pyramid. It might be more expensive, and it might be slower, but the value is infinitely higher. Because that's what we deliver as customers or businesses and to customers is up in that pyramid at the top. And so I like to challenge these kinds of things. We take it for granted sometimes, and someone said it, and we're like, cool, we repeat these things. And so that's why he always shakes my head when I come up with a new idea. But what I want to do is take this concept, the cost and the time of doing visual regression, and push it low down. So we get that benefit faster. So if I said that, like how would we create an automation pipeline? Well, we've already kind of chatted about the compare step, but before we get there, we need to get images, right? So what we can do here is we can use something like Selenium, or Nightwatch, or Headless Chrome. If we boot a browser up, there's a way to get a picture of it. So we can get into a site, we can navigate to where we need to be, and we can get a picture. Given that we've got a picture, we need to use a tool that can just diff out that picture. And there's tons of these libraries. I'm currently going to do a demo. I'm just going to use these tools. And I've chosen ImageMagick. It's a bit of a lower level tool, but it does a lot of other image manipulation things that I like. But you've got tools like Resemble.js or PixelMatch.js, which are just stock standard tools that you can pull in. And then basically, once you've got a comparison, you suck in the output, the yes, the true, false, and the degree of certainty. And you need to write a test that covers that and can give you just your reports. So whatever your tool is, it could be Karma, it could be Mocker. I'm going to do a little demo in Jest. So that's the basic pipeline, doing exactly what we did in the first step. Cool. So you're cool if I do a demo? Yeah? Okay. Code nothing fun?
Hope it works.
So the first demo that I'm going to do is Can anyone read that on the back? It's a little bit small. Maybe
Zoom in.
Zoom in. Thank you. Thank you. So, in this particular test, I'm going to take, I've typed in a library, image compare. It's a bit of a hand-rolled library, but it just loops over the ImageMagick library, and it says, give me two pictures, and I'll tell you if they match. And as a nice little benefit, I will kick out that image difference that we saw earlier. So here's the describe it test. I'm not really good at writing test names, so do that. And what we'll do is we'll take in the new Panda file, and we'll compare it to an existing Panda file and see if it matches. So in this particular one, we have two different images, so we expect it to match. All right, cool. So my test spits out that it failed, and in the directory here on the right, this output directory, it says I expected this Panda image, I got that Panda image, and kicked out this Panda image. Cool. All right? That's how fast that is. That's all it needs to do. And so from me, I run my test cases, I check my code in, and boom, something went wrong. Look in this file, something went wrong with this file. But it's really easy for me to evaluate these two pictures side by side, knowing where I'm looking at. So maybe I'm looking at the leaves. Okay, cool. All right, I'll take the leaf one, and I can move on. So how does that play out if we maybe have an application? So the repo that I've done this code will be up online. I'll give Matt the link, and so you guys can take the time and run it if you so desire.
Thanks, Don.
All right, so over here, what I did is I just created a really basic boilerplate application, and it's just meant to illustrate that at different breakpoints up in the right corner, we're going to change out the icon that we show, we're going to change the background, and we're going to use different font sizes as we cross over breakpoints. So running the app, if I was doing this manually, I would be doing something like this. I'd be okay, cool, it's red, it's a knight. That font looks okay. Okay, it's blue, it's a king. Okay, cool. Cool. All right, so that's what I'd be doing. Then my developer comes, he commits more code. Is it again? Ooh, I hope that's right. And I go on and on and on and on, but it's not really a very valuable thing. So what we're going to do is we're just going to write a test for this. Here, this one's a little bit more, but we're going to use Headless Chrome to get that. And then what I've done on the left here is I set up my test cases. I'm like, cool, there's a small screen. These are the widths that I care about. If it changes that, that's pretty good, it's pretty indicative. And I'll save the image as app. Medium, same diff. I just got a bigger screen size, save that. And then I kind of just do the same thing that I did with the other one. All that I do here is first I set the viewport on my page, navigate to my URL, and I take the screenshot. Okay. Basically, these three lines are almost identical to the first one. So let's take that test out. Let's see if I can get them to side by side. I might. So, okay. So here we go. Automated, kicked off the browser, a new tab, drove the app into the state we wanted and captured the images. And it spat out the results saying all of these screen sizes didn't match because this is the first time I've run this test. So I had nothing to really compare it against. And if we looked in the folder, it's kicked out the actual results for the large screen. The medium screen, the small screen, and the large screen. So this is the first time we run them. We look at this, we're like, cool, this is what we expected the app to be, and we want these to become our baseline. So I'm just going to copy these files here into my baseline folder, and we're going to rerun the test. our baseline folder now has those images. If I was to go to my console and say, please rerun all the tests, get them all out, and they all pass. So, I know it was a bit of a long-winded talk title, but hopefully I've given you enough, like a glimpse that this is not really hard stuff, and it's actually, we've got tools out there, and as tech gets better, we get more tools, and we should always go back and look at what we thought we couldn't do, and figure out, hey, can we do that? Because I don't want to test breakpoints. It's really a horrible thing, and I feel really bad when my testers say, oh, you didn't think about that on this device. So let's do some tools. Let's make everyone's life easier, and then let's have fun. Cool. Any questions, guys? No, no, not yet.
You said you used Chrome Headless, but the Chrome actually opened, so what was up there?
Okay, so Chrome Headless, you can do it in Chrome Headless. Chrome Headless has two modes. It's got like a debug mode, so it actually opens the browser and navigates the tab. And that's pretty useful here just to show you what's happening. It's just a flag setting here. I'm going to reset. So we're going to start the test suite again. And then I go into setup. I can turn that off. And then so I've got a test runner that's running in the background all night. So I haven't taken those new steps. So cool. Tests are failing. We save those and we rerun the test. And they pass. That's Headless Chrome. So now the thing about this and why we would do it like this is we would do this in our CI pipeline. So this is when we check in code in our apps, it goes through whatever our integration test suite tool is. Could be Jenkins, we use a different runner, and we run these tests in our pipeline with this. It's on the dev machine before they go there.
Can I ask? Hang on.
It seems most useful when you're doing regression testing as opposed to actually making UI changes, because like if you're making UI changes, every change you have to like actually manually verify whether or not it's desired outcome. And especially with like you showed also in that one example, like when you shift something, then everything looks like everything's done. So it's like it's the same with like in code. If you indent something differently, it's whole file seems different. Right. How do you deal with that? And small caveat, isn't it like maybe more computer-assisted visual regression testing as opposed to automated?
Matt, give us a t-shirt. All right, so that's like a composite of like 3 questions. Yeah. So I'll try and answer it in 3 different ways. So I've done this talk in different formats for different groups, and in my dev group, I have a lot of developers who are new to front-end development, and CSS is a new art to them. So depending on your workflow, right? Like what I've done, I guess this is the second. See if I can answer the question. So what we do is we use React as a platform, and a page is made up of many components. So we can take an individual component and build that in isolation. And we can regression test against that isolated component. And if you've got a designer who designs like high fidelity mockups, that is your starting baseline. So everything until that thing passes is a failing test. So when we do this test where we start with a blank slate and then we build up a button that matches the spec exactly until our test passed. So you can take the design from a PDF out, take that as your image, and then build something that matches that exactly. So that's like one answer. And the second part, which I was trying to say, is also yes, if you do an entire page, if you move a pixel, and loads of stuff are going to go. So it's really hard to regression test at a page level if your design changes frequently in a global landscape. So if you add a new home button, every test is going to break. But at least at that point you have an identification, and it might be in a place to say, I expect every test to break. If you bundle the code change of changing the top level navigation, which affects all visual regression, with some other like logic change, you're kind of in a bad place, because now you just don't know what caused what, because it could have, you just got to accept it. So in that scenario, what you can do is you can still take a page level, and then you can choose component section and crop those images out. So you can kind of get a composite of the entire page and its composite parts, and if the composite parts are fine, you can go, okay, it's a global change. So it's a bit of like, this is an art, right? Like testing is an art. You're not going to get something that just says, cool, you wrote code and hey, everything works. You don't have to do anything. So I definitely don't think visual regression solves all of our problems. Like, you still need great end-to-end tests and good integration tests and functional tests. One of the other areas where it's pretty terrible is if you have dynamic data and you're hitting a live service. So anything that's date dependent, you hit the live service, the date will change. You'll always get a different image. Or you call an API that's giving you real-time stock data. Well, it's never going to be the same image. So this is a bit more technical, and that's the alluded part to Headless Chrome. But in our test setup, one of the first things we do here is set up intercept requests. Okay, so you might lose one or two people. I hopefully can keep you along for the ride. Headless Chrome allows us to do a lot of things that we do in unit tests. It allows us to mock the network, mock mobile, offline status, anything that you can do from your dev tools, it exposes. So what I'm doing here is I'm actually loading my index.html, or I'm actually injecting the index and the JavaScript bundle that runs through the network. So it's kind of like, I said, cool, what I want to get out of this is that Chrome behaves well and gives me a picture. But as soon as it wants to leave and try and fetch an API, I'll tell you what you get, Chrome. You don't get to do the network. And to prove that, I could just turn the network off, right? Like, and my test can still carry on. Because Chrome's never leaving its sandbox. And so that's a really interesting feature which separates Chrome from something like Selenium. And I think it's per application. If you're doing a very rich UI that uses the JavaScript framework, you can do this technique. If you've got a website that needs to serve pages, then you need to create a mock service that can kind of stub out the data. Cool. I think maybe there's a little too much information. Yes.
That's a question. When you switch off when you make it headless, opposed to when it shows on the screen, have you found that there's a difference when you expect it not to be different, but it is different?
Yes. Testers down. How to be clear and more for the win in the presenting this at a dev conference. Okay, yeah. This is really new, right? Like, Headless Chrome came out middle of last year. The library that I'm running again for JavaScript Puppeteer came out in December. And I kind of like hacked this together early January and was really chuffed with myself. But we run these in Docker containers, so you're always using it headless, you're always using the exact same version of Chrome, and that allows us to have the exact same integrity between every single development machine and our CI pipeline. So there's no differences like that. When Matt said, no, we need to give the audience here something to take home, I was like, yeah, cool, I'll throw Docker away and then I'll just do it and then we can have it headless or not. And for some weird reason, two things are happening. One, when I do it on the Mac, I haven't tried this on another device, but when I do it on my Mac, there's a difference in color that the visual regression picks up. So like, there's something in the rendering on either I'm actually booting my device as Chrome, and there's a version difference, But maybe it's my Mac Retina, and in Chrome Headless, it's like, hey, you don't have Retina, so your pixel quality is degraded one hex code. But there's like a tiny discrepancy, and the problem is like I can't see it. Like when I look at it, I actually just can't see that color. But if I probably did an eyedropper, it's off by this tiny step. The second thing was I saw there was like a tiny, and we're talking. That's why I actually had to reset this. But there's like a tiny 1 pixel difference in the font rendering. And that could be, I need to set the global standard on the fonts and resize that, and I haven't done it in this particular app. But it's something I'm going to be exploring and figuring out, like where that like nuanced 1 pixel difference comes from.